Okay, thank you very much. My name is Susumu Yoshitam. I'm from the Japan Space Forum. I would like to present update status of the Kibo High Vision Earth View educational system. I present this project at last APRSAF meeting in Bangkok, and at that last APRSAF meeting in Bangkok, this working group decided to support our program very strongly. So I would like to proceed our development activities the past year. So this is just information about what is our Kibo High Vision Earth View. This is the educational program using the high definition TV camera on board the Kibo export facility. It will be launched in early 2012 by HTV3. And this is our team members. We are composed of some of the members of Japan Space Forum and space engineering development agents, development companies. People support us developing some software and some web page. And also we have advisory committee chaired by Mr. Takayanagi. He is now Director General of Tamarokuto Science Museum, and also we here is the member of the advisory committee, Professor Arai and Professor Kawakami and Dr. Nakano. He is a science journalist, and also Mr. Ueno from the JAXA was joined this advisory committee, and they made many of the advice to develop our project. So this is the past experience in high definition TV conducted by JAXA. When I was at JAXA, I deeply involved with this kind of activities. For the first time, the astronaut Morrison brought the high definition TV camera on the space shuttle, and also the astronaut Mukai-san for the second time. She brought also the high definition TV camera in this space shuttle flight. And also the JAXA conducted some experiments, HDV shooting by the contract with the Russian Space Agency. So they conducted some demonstration remote medical purposes, and they also can capture the HD image for the educational purposes. So let me introduce some of the Earth image taken by the HD TV camera, showing the Earth, the surface. This is the just example of our project.
日に打ち上げられたエンデバーは11日間にわたって地球の周りを飛び続け、私たちの地球をさまざまな方法で観測しました。エンデバーに乗り込んだ日本人飛行士の毛利守さんは、飛行中ハイビジョンカメラで地球を捉え続けました。毛利さんの観測を地上で支えた東海大学の坂田俊文先生、そして女優の宮崎美子さんと一緒に眺めていきます。それでは日本列島を南から見ていきましょう。種子島、鹿児島の大隅半島から日本列島沿いにシャトルが北上していきます。
the space shuttle. So those kind of the image can be captured by the high definition camera on board the GEM exposed facility. This is just example.
ブロッド南になってますね。足摺りで、その真ん中の弓なりのところの広くなってます。あそこは当地です。で、徳島がちょうど画面の真ん中ぐらい。雲の
Okay, so those kind of the image can be provided by the our educational system, and also the and at the same and also the those image can be distributed at a real-time base to from the space station to the school or some science museum, not only Japan but also other Asian countries and the United States and any place we can do that by using this grant system. So as you know, so this is almost completed space station. This is the our system overview, and okay, so we would like to collect some image request from the school or science museum, and those kind of the requests are gathered into the mission operation center in JSF, and such kind of the request sent to the JAXA Space Center. Then JAXA will operate the onboard high-definition CCTV camera, and then the image can be taken by that camera, and those images go through the Space Center and our system to the visiting school or museum at a real time. Okay, so I'll show you some development status of this part. So the camera will be on board the exposed facility, and the two sets of camera installed on this site. And like this, we have JAXA has two cameras. the payload, this is the multi-purpose exoskeleton payload. One of the payload is this HDD camera. They have two cameras. One is direction of sight is nadir. The other one is 10 degrees tilted to the nadir side, nadir direction. So this is the camera payload. As you can see, this is covered by some insulation, and this is the not covered. You can see this is the power supply unit, some communication unit, and then some control unit. And they have two camera number 1 and number 2. And this is camera number 1. Is the direction of the sight is the nadir, is the other one, the second one. So this is the control unit. So at this moment, those development is successfully progressing, and then integrated into this payload. Then will be launched in 2012, early 2012. And image taken at the GMX facility, image can be transferred to the two ways. One is the UX TDRSS system. The other will be DLCS operated by JAXA. Then any image can be sent to the Scuba Space Center, JAXA Space Center, either the TDRS or GRPS. Then we received those images at the Scuba Space Center. Then we distribute the IGBT image to the school or science museum, something. So this is the HD image live distribution scheme number 1. At the Scuba Space Center, we receive the HD image as a data. So we convert data to the video image can be converted to the IP protocol because we use the internet. So we need such kind of the data converter and broadband router. Through this equipment, we can receive our headquarters office and using the broadband router, and this converter will be used to the we receive the internet protocol format, so we convert to the video image here at JSS Tokyo, and those signals will be distributed by the server. In this case, we decoded this here at this stage. Then those video images can be sent to the via internet. Then the school and the museum can retrieve those images at the PC or some high definition TV. In that case, we need internet capability is about more than 3 megabps. This is the case number 1. And the other case, in case of the internet capability is less than 30 megabps. So when we distribute the image from the site from the server, directory server, then and at the school and the museum, the site, we prepared HD decoder at this destination site. Then they can make image, HD TV or PC. This is the second case. So it depends on the capability of the internet. We have two operation scheme. So in both cases can be verified by in this fiscal year, end of the fiscal year. I mean maybe next February and March timeframe next year. We already purchased such kind of the equipment, data converter, 2 sets of the data converter and 2 sets of broadband receiver and HD decoder. We are going to purchase those equipment. Then we also developing some web page. So this is the content of the public page. We have two sort of the pages on the top. One is the web page to open to public. The other one is open to the participating school and museum people. This is the public page. We provide some general information about our programs, and also we some in the space station program and something like that. So this is the we call the authorized users paper. I mean, once the team registered in our programs, they can access to the this user page. So in this page, we will provide ISS orbit trace display and some other software. With this software, they can make image request and also verify their request, something like that. For example, this is just an example of the orbit trace. As you may know, the ISS, the inclination of ISS is about 51 degrees, so it's 51.6 degrees. So the ISS covered almost the area on the globe. So, but the school students, and they are thinking about some specific point to take a high definition image. So once they are decided to the point like this, they can use our provided software to check when ISS comes over this site like this. So those kind of the software are now developing supporting by the SED company. So, and also we have to careful. We have to know our camera, the HDP camera on the GEM has, as I said before, two cameras. One is Nadia and the other one the 10 degrees tilted. But unfortunately, the direction site is fixed. We don't have any mounting table. So the fixed direction, the Nadia and 10 degrees tilted. And also we can only operate the one camera. We cannot operate the parallel. And we have to be careful the ISS attitude and zooming, because the targeting like this, we must know the attitude of the ISS, and also we have to, when we zooming up in this area by using the zooming function of the HDD camera, so we simulate the how the big image can be taken by HDD camera like this. And also, those images can be transmitted from the space station to the ground via Japanese data relay satellite DRTS or NASA TDRS communication link. So we ask the JAXA to coordinate communication availability among the ISS partners. So this is just an example of the TDRS and DRTS. Because in case of the TDRS, they have lots of the users like Space Shuttle and Hubble Telescope and some other satellite in addition to the space station. So we need the coordination for the allocation of our allocation. So this is just example for the trace of on the Earth. When, as I said before, the space station they fly over the Earth with inclination of 51.6 degrees. So this is just example of the and over the African continent, and this is the Asian, something like that. So we can take image any place on the Earth except the polar region, both polar regions. This is just example. This camera, the field of view of this camera is about 200 kilometers by 350 kilometers without a zooming function. This is a normal area field of view. Just an example. So in this fiscal year, this program funded by Ministry of Education since last year. So in this year, we are going to the key for participating in our demonstration, the purposes, and also some other those we are expecting the school team help our development of the systems by usefulness of some user guide on something. So this is the possible study using these images as I presented last year. And this is the proposal for the collaboration in the framework of this for APRSAF. So we prepared English web page written in English, not only in Japanese but also in English. So all the participating agency in APRSAF, we expect those agencies collect participating school in your country, and also the interpret English to the own language, because we cannot prepare all the language web page. So please interpret between the English and your own languages. And also, we expect your agency to direct school kids how to study through this program. So this is just proposal from the GSF to proceed or collaborate with our educational program. So this is just a tentative schedule proposed to JAXA. Right now we are year 10 here, and our development activity will be completed at the end of the fiscal year 2011. The March 2012. So after that, we will be go into the normal operation with our educational programs 4 times a year. This is my just idea or proposed to JAXA. Before that normal operation, next year, as Kamigai-san and Fujimoto-san present that next year, Dr. Furukawa will be on board ISS for 6 months. So during his flight opportunity, we proposed some demonstration of the educational program by using the camera inside the gym, not the outside gym. This is just a tentative schedule proposed to JAXA. We are now discussing with JAXA, and we would like to make some cooperative agreement or some contract. That's the process is ongoing. So those we like to such kind of the agreement will be concluded at the end of this year. This is my target. So that's all my presentation. Thank you very much.
Thank you. Are there any questions?
May I ask just one question about, do you have data about the resolution of high definition TV from the space station altitude? The footprint is 200 kilometers by 300 kilometers, but how about the resolution?
Concerning the resolution of this kind of the video, we cannot specify that because when we take some digital camera like a remote sensing satellite, we can say the our resolution is a certain number of the meters or something, but this is just a video, so we cannot specify the resolution. But many years ago, when I was in JAXA, I discussed with this matter with NHK people. So he said, roughly speaking, in about 100 meters, something like that. It's just based on some assumption. So comparing to the digital camera on board existing on board ISS, and in that sense, this resolution, HD camera resolution is less than the digital image. But this is the video, so we have another variable information can be taken by this high definition TV.
May I ask you some of stereographic view of high vision TV? high definition TV. You have two linear and tilted camera, so you will make some of the stereoscopic high definition TV imagery.
Yeah, that is a good question about this. Because of this camera is, as I said before my presentation, this camera is a purely commercial-based camera, so it's not specified to the space use. So just the people expecting that the lifetime of this camera, their hope is about more than 1 year. So we have to, we would like to continue this program, not only less than 1 year, we continue this program. So we have to prepare the second and the third option to of the high definition camera. So the most probable way is using the camera inside the ISS from the cupola windows. So it can be easy to achieve this second option, but I hope to develop a second or third generation of the HDTV camera, so which is supported by not only space agencies but also other space industry and people. My idea is the camera pointing to this the Earth, and not only the Earth but also the astronomical purposes. We can look down and then looking up. So many people are very interested in my ideas. So I would like to discuss the realization of this the concept with your help.
Hello. So do you use the astronaut resources to repair your high definition TV installed in exposure facility? No preparation for repairing or some sort of change of the high definition TV?
Yes. This camera, the advantage of this camera operations, we can operate on from the ground. We don't need to support an astronaut on board the space station. They just press the button for the communication link. Then the camera operation can be done by on the ground. So even the astronaut will be sleeping, we can operate. We don't need astronaut support operating this camera. So that is a big advantage for us.
This for the educational purposes, is it possible to mix kind of the program that participating countries in Asia can propose the observational object, for example, the tropical forest or the coastal area and something like that, that maybe, and then the student can discuss, for example, the effect of this climate change and something like that. Is there any theme, the certain theme for the each mission for this using this camera? Thank you.
So of course we will welcome your participation to our programs. If you want to take such kind of the image from using this HDTV camera, we can provide that image to you from the early 2012. Then, but when you study about such kind of rainfall around the countries, I would like to advise you to not only using this kind of the image, but also other remote sensing satellite data or something. So the combination of those data or the images, you can study more deeply. Yes, of course, you're welcome to our programs.
Thank you very much. We have to move on to our next speaker now. Thank you. Now I'd like to welcome Dr. Phil Wilkinson.